Switch number 1 is already up and running. We already have added our sites and everything. So if I go to global design network hierarchy, we can see that we have added the sites. Then we can go to the network settings. We have added all the necessary things, such as, for example, DHCP server information and the rest of the things. We already have added the device credentials and all. Now, then we went to the provision, we went to the inventory, we already discovered the devices. One device we discovered via discovery, and the second device we actually added manually in this graphical user interface. Switch number 1 in branch number 2, this device that we have added. This device is this seed device, which will be used to discover the rest of the devices in this branch number 2. So this is this device, this switch number 1 that we have here. It is switch number 1 on branch number 2 is reachable from the DNS center, as you can confirm. If I change it to inventory, you can confirm that it says reachable and everything. So this switch number 2 is actually completely up and running. Now we can start onboarding. We can now start using this process of LAN automation. So earlier this LAN automation used to be here, like go to the provision, go to the inventory, select the appropriate device, then go to the action, go to the provision, and here earlier we used to have the option called LAN automation. But nowadays what they have done in this release 2.3, they have removed the LAN automation and they have given right outside, like here we have this feature called LAN automation. So the LAN automation feature that we have here, LAN automation feature is actually used to bring up the devices in the underlay in a complete automated fashion. So DNS Center is designed to automatically discover and configure our underlay network with the help of a feature called LAN automation in the SDA environment. So if we have like multiple devices, we do not need to set up all the devices one by one. All we can do, we can set up like just one device. All we can do is to set up one device, and the rest of devices can be discovered and added automatically in the SDA network with the help of this LAN automation feature. So what are the prerequisites for this LAN automation feature? The prerequisites for the LAN automation feature is that site hierarchy must be configured. Okay, we have already done that. We have already configured our sites, locations, and everything. We have configured it in the hierarchy section right here. So in the design network hierarchy, we have already configured our site hierarchy. So site hierarchy is already configured. We have already configured all the necessary sites from one point to other point, you can see. So we have configured like all the sites. So this is already configured. So site hierarchy must be configured. Network settings must be configured, such as like network settings must be configured as well as the device credentials. Okay, that we have done as well. So we went to the network settings, and we have configured whatever things we wanted to set. So on the global, we set some things. On the site location, we set some things. So network settings are configured, and also we have set the device credentials. So device credentials, whatever credentials were required, that is also set. So this is also done. In the device credentials, username must not be admin, because admin is used by the identity services engine. So username, you cannot take admin. So username must not be admin, because admin username is already used by the identity service engine. So there will be a conflict. So username cannot be admin. So in the device credentials, username must not be admin. Now, next thing is that, which is important. Now we need to configure a pool. So what this LAN automation feature is going to do? This LAN automation feature is going to configure a /30 subnet here, /30 subnet here, /30 subnet here, /30 subnet here, /30 subnet here. It is going to configure /30 subnet, and it is also going to configure the loopback 0. It is going to configure all these things like in an automated way. So we need to tell the DNS center, we need to actually define in the DNS center actually from what pool the IP address will be given onto this particular, these links, what IP address should be used, what pool of the IP should be used to configure the IP addresses onto these like interfaces. So this, like, we need to configure a pool. An IP address pool for the LAN automation must be configured. Cisco recommends just minimum /25 subnet. However, we can choose like as per the number of nodes that we wish to automate, we can choose as per our requirement. So what this LAN automation is going to do, DNS Center is going to assign a P2P /30 subnets onto the links between the switches, and /32 subnet onto the loopback onto those particular switches. So you need to calculate, for example, here in this situation, you actually need to calculate, here you need to calculate, like if we are going to use the LAN automation feature, like how many number of IPs we will require. So 2, 2, 2, 2, 2, 2, 1, 2, 3, 4, 5, 6. So 12 IPs we will require here, and then 13 and then 14 IPs we will require in this entire, I would say, branch for the LAN automation. So you have to configure the pool in such a way that all these links can be configured with the IP address, and the loopbacks can be configured with the IP address settings as well. So Cisco recommends that you have a /25 subnet. You configure like 10.1.1.0/25, for example. What DNS Center is going to do, it is going to break this into /30 subnets, and it is going to break it into /32 subnet. /30 it will assign it on the P2P links, and /32 it will assign on the loopback, and that will be done automatically. We just need to configure enough IP addresses on the DNS Center so that the DNS Center can configure the links between the switches and can configure the IP addresses onto the loopback interface. And this pool that we have configured must be reachable from the DNS Center. You need to make sure that the reachability is there from the DNS Center. Otherwise, DNS Center will not be able to reach out on there. So let's configure the pool. How can we configure the pool? Again, go to the design, go to the network settings, and right here we have the option called IP address pool. So I will go to the IP address pool. We cannot create the IP address pool directly on the branch level or on the site level. We cannot do that. What we need to do, we need to create the pool at the global location. So you go to the global, and here you can add the pool. You cannot add the pool directly onto the branch. You cannot add the pool directly onto the branch. You will go to the global, and here you are going to add a pool. So go to the global, click on add button, and here you define like pool for LAN automation, something like that. I have configured it. This is a generic pool. This can also be used for the tunneling. So generic, I'm just going to choose generic. So if you mouse over it, it will show you. If you mouse over it, it will show you. Tunnel means like choose tunnel to assign IP address to site VPN, a generic for all the other purposes. So since we are not going to use this pool for IPsec, like LAN to LAN IPsec, we are going to use it for normal LAN automation purpose. So we are going to choose it generic. Then either IPv4 or IPv6. So IPv4, what subnet I am going to configure. Here you have to define the subnet that you wish to use for the LAN automation purpose. So I'm going to choose a random subnet that I have not assigned anywhere. So random subnet you need to choose. I'm going to choose like 195.195.195.0. You can choose any 195.195.0.0/16. Ideally, what we do private IPs. So I don't remember like what IPs I have configured, like 10.99 I remember I have already configured 10. We can also configure a private IP such as 10.75.0.0, something like that. Hopefully I have not configured this anywhere, because if you have configured this IP anywhere, your LAN automation pool will not be reachable from the DNS Center, and the LAN automation process will not work. So this pool must not be like configured anywhere else. So 10.75, hopefully I have not configured anywhere. So 10.75.0.0/16. Gateway IP, DHCP server, we don't need to provide because this is just being used for the LAN automation. When we configure the pool for LAN users, then we can configure these things as well. What we do, we configure the gateway IP, we configure the DHCP server that we set earlier, we configure the DNS server that we set earlier as well. So once we have configured the DHCP servers, we can use those DHCP servers here. Once we have configured the DNS server, we can use those DNS server here. We will see that later on.
So what is their option? Is there generic?
Yeah, you can mouse over it and like.
No, that is there any other options out there?
We click generic and tunnel.
Okay.
Yeah. So if you mouse over it, it will show you what other options are there. So one is generic, one is tunnel. Tunnel is for site-to-site VPN. So since we are not going to configure any site-to-site VPN, so we just need to put on the generic keyword. Right. So 10.75. 10.75.0.0/16 is going to be the pool that we have reserved for the LAN automation. It is a private IP, so it's okay. So in the global level, what we are going to do at the global level, at the global level, we are going to create the pool. Then I will go to the branch level, such as, for example, branch level, I will go to the USA, New York, the Wall Street. I will go to the branch level. Here, for example, we have a few set of devices that we wish to automate with the help of the LAN automation feature. I will go to this branch level, and on the branch level, I'm going to reserve the pool for the LAN automation. So reserve basically means like we configure the pool at the top level of the hierarchy, and then we reserve the pool, reserve the IP addresses from this global pool onto the branch level. So like I will go to the global, I will configure the pool, then I will go to the like branch level, and I'm going to click on reserve. I would say BR2 LAN automation. So automation, and this is going to be again generic LAN. These are other options. These are a lot of options available here. You can mouse over it and you can see everything. So once you mouse over this option button, it will show you the details about all these options. Since we are using this tool for the LAN automation, we must select the keyword LAN here, because LAN keyword here is for the LAN automation. See, management type is service subnets, WAN for the UCSE provisioning and all that, whatever it is. So either you choose generic or you choose LAN, because these two things are useful to us. So we are going to use LAN for the LAN automation purpose. We are going to use generic for all the other purposes. So just choose LAN here, because when you mouse over this options, you see this LAN stands for LAN automation. And now here you are going to say that, okay, do one thing, inherit the IP or get the IP from this pool. So this is the main pool, and from here I'm going to borrow a /24 subnet of 10.75.2.0. So from this pool, from this global subnet, I have reserved this particular subnet 10.75.2.0/24 for the LAN automation purpose in branch number 2. So you configure the pool at the global level, then you reserve it onto the branch level. So you must configure this LAN automation pool before you can actually use the LAN automation feature. So branch to LAN automation, type LAN, this one, and this one. You don't need to configure the gateway, DHCP and all these. If you want, like, you can give the information about the DHCP servers that we have configured. If you want, we can give the information about the DNS servers that we have configured. If you want to do that, you can give that. You can put the information about the DHCP server, DNS server. In fact, the gateway is 10.75.2.1. However, it's not going to be the gateway anyway. So you can give the information about the DHCP server and the DNS servers. So in the same pool. So this DHCP server and the DNS server we set earlier in the network settings. Now we are just calling those DHCP server and DNS server right here in our pool. So branch to LAN automation, type LAN, the pool 10.75.2.0/24, and DHCP server and DNS servers we have. This you then click on reserve. So from that global pool, now certain set of IPs will be reserved for that particular branch for LAN automation purpose. Same thing you could have done on here as well.
Can we add as well for voice for another subnet?
No.
Camera for another
No, we cannot. We don't need to do that right now. So since we are using this only for LAN automation, we will stick to the LAN automation. When we talk about the host onboarding, then we will see the rest of the pools. So this one is only for the LAN automation. That is the most information that you need to give, and that's okay. That's enough. That's all the information that you need to provide. That's enough. Rest, like we will see other types of pool later on.
So the /25 is on the global level or on the
No, /25, like I did not use /25.
I know, but it is on the which level? The limitation.
This is like on the branch level.
On the branch level, okay.
Yeah, on the branch level, they recommend that a minimum, like on whichever branch you are going to use, like LAN automation, a minimum of /25 subnet you should use. But you can change that as per your requirement based on like how many number of nodes you wish to automate actually.
Okay, thank you.
So similar to that, let's say for example, we have a few devices in the Mumbai location. We have a few devices in the Mumbai location where we wish to use this LAN automation feature. I can go to the Mumbai location, and here I can also reserve. I can say, like, for example, similar kind of thing that we have configured here, BR2 LAN automation. I'm going to similarly go to the Mumbai location. reserve, and I'm going to say maybe we have a few devices. We have a few devices like in branch number 1, right? So here also I'm going to use the, I want to use this LAN automation feature. So branch 1 LAN automation, I'm going to say like Mumbai, and here I'm going to use again same LAN. Here I'm going to use the global pool. Here I'm going to use again /24, maybe 24, 25, whatever you want. Then subnet is going to be like subnet is going to be 10.75. Let's say for example 11.0. This is the subnet that I'm 10.75.11.0/24 is going to be used for the LAN automation on the Mumbai location. Additionally, you can provide the devices with the information about the DNS and domain name. However, this will not be needed for the LAN automation. This is just for information that we can provide the IP address of DHCP and DNS server while configuring the pool. Same thing, you can go to maybe for example I-Medita location. You can go to here, and on the I-Medita location or in the Pune location, go to the Pune location, again reserve a pool, branch 1 LAN automation for, let's say for example Pune, and here we are going to configure it for the LAN global pool, and I'm going to say the prefix length /24, and then I'm going to configure the subnet 10.75.12.0 DNS and DHCP, and information we can give if you want. However, it will not be needed. So 10.75.12, if I try to give 10.75.11, it will not allow me. It will say that it is already being used, so you cannot use the same. So 10.75.12 I'm going to use here. So whatever pools you have already reserved, obviously you cannot use them. So now this time I configured this pool at the Pune location, and if I go to the I-Medita location, the pool got inherited. If I go to the second floor, the pool got actually inherited. So same hierarchy goes for the pooling as well. So if you configure some pool at the global, then we can reserve. We create the pools on the global, then we can reserve the IP addresses from those pools in the branch location, such as for example Mumbai, such as for example in Pune. And if you configure anything in Pune, like all the lower level in the hierarchy, they are going to inherit that particular pool. So you go to I-Medita, you can see this pool got inherited there. You can go here and you can see this pool got inherited here. Same here we configured it manually. A pool will be required for the LAN automation feature to work. A pool has to be there. A pool must be present for the LAN automation feature to work on that location. So site hierarchy already configured, settings already configured, credentials already configured, pool already configured. Now we have to make this pool reachable from the DNS center. We need to make this pool reachable from our DNS center. So as per our topology, this is our topology. In this topology here, we have our DNS center. DNS center must be able to reach to that particular pool 10.75.0.0. That pool DNS center must be able to reach. So on the DNS center, we have already given a default route or so no worries. On the DNS center, we already have given the default route. Using the default route, packets will arrive on the management switch. From the management switch, actually I need to make this subnet reachable. And remember that we have already configured our branch 2 switch number 1. We already have configured our seed device. We have already configured our seed device. So you can take a look at the seed device quickly. Let me log into the seed device, so which is like switch number 1. So this is our seed device, this is our main device. Branch 2 switch number 1 is our seed device. This is our main device that we have. This is already like reachable from the DNS center. Wait. So this is our seed device. So show, like you can see, ping 192 168 10.231 source loopback 0. You can see that the ping is successful. So this is our seed device, which is already reachable to the DNS center. And what IP I have configured here? Show IP interface brief, pipe exclude unassigned. So the 192.168.238.2 IP address is configured onto this particular interface of our seed device. So I'm going to go to the management switch. Let me log into the management switch as well. This is switch number 1. This is BR2SW1. Now I'm going to go to our management switch. I will go to our management switch, and from the management switch, I'm going to make this uh, from the management switch, I'm going to make that subnet reachable. So this is the subnet on the management switch. On the management switch, I actually have this subnet here, like 10.75.0.0/16. I can go on this management switch and I can say IP route 10.75.0.0 to 55 to 550.0 and the IP address that we have configured on here. So I'm basically doing static routing. I'm just doing the static routing to make the pool for LAN automation reachable from our DNS center. So DNS center will use the default route, reach to the management switch. On the management switch, I have given a static route. Using the static route, the DNS center will send the traffic to the switch number 1, and switch number 1 is going to have like these subnets 10.75. whatever it is. So here we have configured a static routing, or what we could have done, we have already configured the IGRP between our management switch and the switch number 1. We can confirm it. We can go to the branch to switch number 1, show IP EIGRP neighbor. We already have configured the EIGRP. So IP route EIGRP. We already have configured the EIGRP. All we needed to do was router EIGRP and just advertise that network 10.75.0.0, 0.0.255.255. So this is also what you can do. Since EIGRP is already configured, between the management switch and switch number 1. So as soon as the DNS center pushes that pool information on their 10.75 subnet, that 10.75 subnet can be advertised via EIGRP to the management switch. So that you could have done as well. Otherwise, you can just go to the management switch and configure a static route. Both will work fine. Whatever mechanism, whatever method you think is suitable for your deployment, you can go for either simple static routing, or you can advertise that subnet in the protocol that we have used to make the switch reachable with the DNA center. Both the options. In short, you need to make sure that the reachability is there. Reachability is there for that pool 10.75.1 with the DNS center. So DNS center already is configured with the default route. On management switch, either you can configure a static route to reach to that subnet, or you can advertise the subnet information in EIGRP so that that subnet reaches out to the management switch. Both the options will be there. Whichever you think is okay for your deployment, you can use it. So this is done as well. So LAN automation pool must be reachable from the DNS center. So for example, there is a question. The question says that we don't actually need to advertise like /24, because anyway in the branch 2 what we are using 10.75.2.subnet we are using now, so we don't need to advertise this entire. But if you remember our EIGRP classes, this command is not to actually this command is not to advertise the subnet. This command is just to tell the device to enable EIGRP on the interfaces. So eventually 10.75.2 subnet will be advertised. So it is just to enable the EIGRP. So anyway, both the things are correct. I did not want to take any risk. So I just, whatever pool I have advertised, whatever pool I have configured for the LAN automation, the entire pool I have configured here. However, this command does not say in EIGRP, in any IGP protocol, network command is not to advertise that network. Network command is to tell the device to enable EIGRP on all the interfaces that belongs to this network. And then whatever subnet is configured on there will be advertised. So eventually 10.75.2 is what we are going to see onto the management switch. So it's okay. So whichever method suits you, either go for the static routing, go for dynamic routing, whatever is okay. All you need to make sure is that that management pool, that LAN automation pool is actually reachable from the DNS center. Whatever IP will be configured by the DNS center for the LAN automation purpose must be reachable from the DNS center. Seed device must be configured manually and added to the DNS center. Already done. Seed device is the first device that first hop device that must be reachable from the DNS center so that it can be used for the LAN automation purpose. So already done. This part is already done. We have already configured our seed device. That seed device is branch 2, switch number 1. That is already up and running. That is already reachable from the DNS center. That has already been provisioned from the DNS center. So that requirement, that prerequisite is also done. So these are the things that you need to make sure are okay before you begin your LAN automation process. Now you can begin the LAN. Rest, if you face any problem, you need to troubleshoot. One more thing, your devices should be in the ICD mode. Like your devices should not be. You do not need to give any. This should be right here. You don't need to actually hit enter or whatever. Your devices should be in the ICD mode. ICD means initial configuration dialog. So your devices should be in here. You do not need to hit enter or anything. If you do that, the LAN automation process will not start. Simple. So just for the sake of the, because, so your devices should be in the ICD mode right here. Your devices, you don't need to hit enter or anything. If you say no or whatever, so the process will just not work. So your devices should be in right here in this initial configuration dialog mode. More like your devices should be in out of box state. You don't need to put any configurations on there.
How do we know that the LAN automation completed or in this week?
That you will know when we start the LAN automation. So
Okay.
you have to
We started it.
Yeah, we have not started it. So you have to also make sure that the devices are in the ICD mode. Otherwise, your LAN automation process will not work. So either you can restart the device, even though the devices are in the ICD mode. So it's quite okay. No need to worry. Now we can begin our LAN automation process. So I will go here. I will go to the provision and I will go to the LAN automation. And here I can begin the LAN automation process. So right here on the top, we have this option called see right here. So everything we have already covered. So create the network hierarchy, done. Define the network settings, done. Define the device credentials, done. Define the IP address at the global level, done. Define the IP, reserve the IP at the pool level, done. Then discover the seed device, done. Provision the seed device, done. Start the LAN automation then. So just click on start LAN automation. Provision LAN automation. Start LAN automation. You can click on this box so it doesn't show like this prompt again and again. Click on let's do it. So where is your where do you want to start? This they have given like in a very wizard type of way nowadays. Earlier this was a little bit different. In the earlier we need to go on to the provision, then from there go to the device inventory. From there we need to actually start the LAN automation. In this new version, they have moved the option and they are giving more as a they are giving more of a wizard way of configuring this LAN automation. So I will define the location where we have this LAN automation. So I need to mouse. Yeah. So I need to select the location where we have the LAN automation, where we want to start the LAN automation. So we want to start the LAN automation in branch number 2. So I will select that particular location, and here it will now reflect the seed device. So if you click on like USA, there is no seed. Like in the USA location, we do have configured a device on there, so it shows there. If I go to the India location, it shows there. But you know the problem is that this device, like in India location, we have branch 1 and branch 1 switch number 4. Here we don't wish to start the LAN automation. We want to start the LAN automation exactly at what location. We need to select that. So we wish to start the LAN automation on the Wall Street here. Click on this and select the location. Select the switch, that is your seed device. So this is the switch. This is the switch. This is the device that we are going to use as the seed device. We can also have an optional seed device nowadays. If you have like 2 devices, there could have been, I could have set up like this device as well. And if this device is not reachable, then this device can be used as the seed device. That's all. That option is nowadays there as well. So secondary seed device, a secondary seed device can also be used in your deployment. but we are not going to configure it. We are just going to stick onto the main like one seed device. So branch to system number 1. Now here we need to select the interfaces. So if you take a look at the topology here, if you take a look at the topology here, we have on system number 1, 19, 20, 21, 22. These are 4 interfaces that go towards system number 2, that go towards the system number 3. So we need to select those interfaces right here in this LAN automation process. So what interfaces are there? Those interfaces are 19, 19, 20, 19, 20, 21 and 22. These are 4 interfaces on the seed device that go towards the rest of the devices as per our topology. So how do you know that? Because you have connected the devices, so you should know that what interfaces are going towards the next devices. So on system number 1, we have 1920 going towards system number 2. On system number 1, we have 2122 going towards system number 3. So we have selected what interfaces are going towards the rest of the devices, 19, 20, 21, 22. Select the interfaces, click on the next button, click on the next button, select the interfaces, click on the next button. Now here it says like once the devices will be discovered, once the devices are discovered, where do you want to actually place those devices? That information you need to provide on here. So once the devices are discovered, I want to place those devices right on here, right on this, the same location, right? So the main IP address pool for the LAN automation, the one that we created, will reflect here. So if you did not create this pool, it will not show it here and you will not be able to click on the next button. So this is the pool that I want to use for the LAN automation purpose. You can mouse over it and the main IP pool is used for the device management IP and the DHCP server pool. This is also used for the links if overlapping links pool is not provided. So overlapping pool basically means like if we have like same pool on 2 different locations, then we can define this as the overlapping pool. Since we have not configured a common pool for 2 locations, so this option we don't need to provide. So here we are going to define like once the devices get discovered, where do we want to place it? So the discovered devices will be assigned to this particular site. That's what we are going to define. Select the site where the discovered devices will be assigned. So discovered devices will be assigned onto the wall state, and those devices will be configured with the IP address pool on this one. And if you wish to, let's say for example, all the devices that are discovered onto that, I want to give them this prefix, like discovered device hostname prefix. Like every device that gets discovered will be configured with the name the name will start from BL2. So BL2 is the prefix for all the device host names that the DNS center is going to configure. We can also download this Excel sheet. Here we can put the serial number. We can put the serial number of our device, and we can put the prefix like host, like I want the host name to start from this prefix, this prefix, this prefix, so that we can fill in the Excel sheet and we can upload this Excel sheet right here as well. So based on the chassis number, based on the serial number, it can choose the prefix that you want to configure on there. Right, so you need to choose the device, you need to choose the site where the discovered devices will be added. Then you need to use this option. You need to define like what pool we should use for the LAN automation. You can also define that all the devices that get discovered will have BR2 dash as the prefix in the host name. Like host name will always start with BR2. And in the advanced attributes, you can configure the ISIS password additionally. So the LAN automation feature is going to configure the IP address on all these interfaces and configure the ISIS protocol in the underlay automatically. So when the ISIS protocol is configured in the underlay automatically, I want to use the ISIS domain password to be this one. The only thing that we need to give about the ISIS is the password. And that too also if you want to give it, not necessarily that you need to give it. We can also enable the multicast. If you know about multicast, we can also configure the multicast right from here, but we are not going to do that at the moment. So yeah, that's the settings that we need to configure and done. Review. interfaces, like this is, here you can review all the things. So for example, what is your seed device? What are the interfaces on the seed device? The discovery devices will be added into this location, the pool, ISIS password, multicast, if you want to enable it, advertise LAN automation routes in the BGP. If you want to advertise the LAN automation route in the BGP protocol for the outside of the network, then you can do that. And all the devices will start with the prefix BR2. Yeah, let me know.
So the switch, the seed switch, using EIGRP to the northbound and ISIS with the neighbors,
Southbound,
right?
yes,
With the,
yes.
okay.
So on this seed device, on this switch number 1, we have configured EIGRP so that we can reach to the DNS center. Like this is more like the outside the SDA fabric, right? So this is outside the SDA. And inside the SDA, we have configured, like actually DNS center is going to configure the ISIS. So what will happen? What will happen here? The DNS center is going to configure the ISIS, and this device, switch number 1, which is our seed device, will be responsible to provide a default route, so that these devices, they can reach to the seed device. From seed device, we have all the exact route, so no problems. No need to redistribute EIGRP, ISIS, ISEIGRP actually.
Okay, so that's why they need the seed file. Okay, the seed device. Okay.
Yeah, on the
In order
seed
to know
device.
how to go to the gateway. Okay.
No, not the gateway. Not the gateway. Because of the DHCP.
No,
DHCP.
the seed device is know how to reach the DNA.
Seed device knows how to reach the DNAC, and seed device will be used as the base device to configure the IP addresses on these interfaces. And so this seed device will be used as more like the default gateway. We have not configured that as the default gateway, but it will be used as the default gateway for these two devices.
Because what I'm saying is because that the seed switch is reachable to the DNA, and it will be used as a gateway for them.
Yeah.
Is that correct?
Yeah, that is correct. So everyone is going to use that IP address and routing and everything that will be configured by the DNS center to reach to the switch number 1, and switch number 1 will further use the EIGRP protocol to reach out to the DNS center.
Thank you.
So one query, if switch 3 don't have any connectivity with switch 1, whether it will be discoverable through LAN automation or not?
No, if the reachability is not there, if the connections are not there, then no. If
it have a connectivity with switch 2 only, means
that is possible. Yes, that is possible.
If I don't put the interfaces of switch 1 interface towards switch 3, 2122, if you don't put on LAN automation, whether it will be discoverable?
It can be discovered, like it can build the underlay network in that situation as well. So switch 1 and switch, first of all, it will configure the things on the switch number 2. Then it will use the CDP protocol to discover switch number 3, and it will come to know about the links and all, and it will also configure the IP addresses and everything on there. So yeah, that is possible.
Okay.
So let's begin the LAN automation, because it not always gets successful. So I can click on the start button right here. So now what will happen, once we have reviewed all the settings and all, we can begin our LAN automation process, and it will start the LAN automation. Let's wait. So now it will log into the seed device and do whatever configurations is needed. So successfully started the LAN automation. Now you can just see that here, that the LAN automation process has started, and status is currently initialized. Until you see here completed, you're not going to do anything. You will just wait. So it says initialized. I can click on see session detail. I can click on this, and it will show me like in detail the information about the things that are going on in the background. So like seed device, this is the seed device. The seed device that we have configured is this one, and I can also check the logs, what is going on in the background. So what happened? So far, what has happened? So started the LAN automation by the administrator. Started the network orchestration session with the primary device branch 2, switch number 1. Then reserved this subnet for the interface VLAN 1 on the device. Since we have already configured the IP address on the loopback interface, it did not reconfigure the loopback interface on our seed device. The loopback interface is used as it is. I started the seed device configuration phase, completed the seed device configuration phase, and now it will begin the rest of the process. So far what it has done, So far, the DNS center has reached out to the seed device and it has configured something on the seed device. What has it configured on the seed device? It has configured an IP address on VLAN 1. What DNS center has done? DNS center has reached out. DNS center has reached out to the switch number 1. It went on the interface VLAN 1. It has configured it with an IP address and it has started the DHCP services onto the VLAN 1. So that like these devices can use that because everything is in VLAN 1 by default. So these devices can use that VLAN 1 to reach out to the next switches and so to discover for the discovery purpose and so this is what is done so far. So seed device configuration phase is now completed. Also see something is going on here. Something has happened here. I did not hit enter or anything, and you don't need to press enter or anything. So something is done here. We need to wait. Okay.
So
yeah.
Go ahead. Sorry. Go ahead.
On the switch number 1, you can see show IP interface brief VLAN 1. I did not configure this. It is automatically configured. And this is already 10.75.2.0. This is already actually reachable from the management switch. We'll let this process complete, then I will explain it. It is almost there. Okay. So just wait. Let this process complete, then I will explain. So at the moment, what has done? One device has been discovered. At the moment, two devices have been now discovered, and it is status claimed. So it is doing something in the background. Let this process complete once, then I will explain what is going on. Do not do anything on these devices. Not enter, nothing. Don't do anything on this. Just because you see not successful, do not press enter or anything. It will break the whole LAN automation process. Let this process complete, then I will explain. Go ahead, like meanwhile, if you have any questions.
So if VLAN 1 used for any reason on the switch, it will create a new one?
Yeah, no. Let me explain. So by default, remember that on all the switches, we have VLAN 1, all the interfaces in VLAN 1, right? And VLAN 1 actually is also used for this thing called PNP. PNP stands for plug and play. So what happens like when a newly added switch, let's say for example, switch number 2 boots up, what it does, it starts its PNP process. PNP stands for plug and play process. In the LAN automation, eventually it uses the PNP process. PNP stands for plug and play. What happens like this switch, in the PNP process, what happens that the switch number 2 is going to reach out of the interface VLAN 1. It will use the VLAN 1 interfaces to reach out to discover like, the controller, DNS center and all those things and try to get the IP address from somewhere and then reach out to the DNS center. So VLAN 1 is used. VLAN 1 is used because by default, all the interfaces on the switches are in VLAN 1 and VLAN 1 is used by the PNP process by these newly added devices to discover the DNS center and to reach out to the DNS center and so that the LAN automation process can actually be completed. And that also comes to the point that also like brings me to the point that on the seed device, VLAN 1 must not be configured. If you have on, let's say for example, if you have configured on the seed device interface VLAN 1, right, with some IP address or so, again your LAN automation process will not work.
Yeah, that's the question, which is we cannot use it. Okay.
LAN automation process will not work if you have configured like VLAN 1 onto the switch, because eventually the VLAN 1 is used by the switches in the LAN automation, PNP, and these kind of processes. Still it says in progress, so we need to wait. Until it says here completed, we need to wait. We are not going to click on stop LAN automation until we see here completed. So like when it says completed, then we start the LAN automation, then the real things actually happen. So I will still wait. Like provision device. I can see like it is almost done. So now we just need to still wait for like this to show actually completed. Until it shows completed, in progress, till it is in progress, until it shows completed, I'm not going to click on stop LAN automation button. So far 2 devices have been discovered and 80% almost like PNP provisioned and all. So 80% of the process is done. Now we need to wait. So I believe, when did we start this process? We start the process at 8:46 actually, and it's been 8:53, approximately 8:51, 8:53. So sometimes like it has taken, it's not that much. If you had like a lot of devices, the amount of time it will take to configure all those devices one by one is going to be way too much. So now done. It says like successfully provisioned. So discovered, provision, this is done. Let's wait for this to show me completed here. In progress. Let's see what's going on in the logs. Added the device to the inventory, added the device to the inventory. So now here you can see that the devices have been added to the inventory. Now let me explain what has happened overall. Let me explain what happened in the background once we start this process. So first of all, started the LAN automation by administrator. Okay, so we already had configured our seed device. This is our seed device, switch number 1. Then we started our LAN automation process from that seed device. Okay. Then what happened? The DNAC center reaches out to the seed device. So starting the LAN automation by the administrator. Then DNAC center started the network orchestration session with the primary device VR2 switch number 1. So the DNAC center actually is now going to start the LAN automation process using this device switch number 1 as the seed device. So what it is going to do, it is going to go on the switch number 1, configure the interface VLAN. It is going to configure an SVI for the VLAN 1. So it is going to create an interface VLAN 1, and it is going to configure the IP address from the pool that we have used for the LAN automation in that branch. So in the branch number 2, the pool that we decided for the LAN automation was 10.75.2. So what it did, 10.75.2.0/24. This was the pool that we were using actually for the LAN automation in branch number 2. What it did, it automatically performed the subnetting. So it reserved a dedicated subnet on interface VLAN 1 on the device switch number 1. So on here, it configured an IP address on the interface VLAN 1. It will be the first IP. So 10.75.2.1/26 actually IP address it will configure on the interface VLAN 1. It will also try to configure the IP on the loopback, but since we have already configured the IP address on the loopback on the switch number 1 on the seed device, that IP address will be reused. Like 10.2.255.11, this IP was reused by the DNAC center on the loopback one. Then it will configure a few things on there. At the moment, it has just resolved it. Now it will push the configurations on the seed device, such as, for example, it will put like interface VLAN 1 IP address, then it will create the DHCP pool for VLAN 1. It will try to give the IP address to any device that gets discovered after the LAN automation process. For that, it is going to configure the SVI and the DHCP pools and so. So up to this point, the configurations of the seed device was done. Some additional configuration on the seed device was done. Some additional configurations on the seed device was done in these steps, like 1, 2, 3, 4, 5. These 5, 6 steps, whatever these are. Here, the seed device configuration, some additional configuration on the seed device was actually done. Additional configuration such as IP address on the interface VLAN, configuring the DHCP so that IP address can be given to the neighboring devices that are using the PNP process to get discovered and get automatically onboarded onto the network. Then, since we have configured the interface 19, 20, 21, 22, then what it did actually, as you can see, it configured an IP address 10.75.2.66/31 on the interface gig 1/0/20 on this device. So what it did then, it went on the switch number 1, which was our seed device. It went to the interface number 20, and on the interface number 20, it configured the IP address from this particular subnet. Then it got to know about the neighboring device. It got to know that there is a device connected on the neighbor side of it. neighbor side of this interface 20. So what it did, it reaches out to that device, it configured 10.75.2.65 on the loopback interface onto that particular device for the PNP purpose. So it reaches out to the switch number 2, it configured the IP address on here, it also configured the IP address on the loopback 0 interface from the pool that we have already configured and provisioned. Image upgrade is skipped. So if we can also write here, we can also push the software image upgrade. What we could have done, we could have marked the image. We could have marked some image as the golden image. We could have marked the image as the golden image. Golden image, more like if we mark an image as the golden image, it means like it is an standard image. It is like the perfect image for like all the switches and also. So we, based on our requirement, can mark an image as the golden image. And since we have not done this, image upgrade was skipped. So SWIM, software image management, this image upgrade process was skipped because it could not find anything to upgrade regarding the image, right? So that image upgrade was skipped. And see right here it says claimed one device and generating the configuration file called br2.1. So br2, why? Because we gave the name, and 1 since this is the first device, so the 1. Then it reaches out to the second interface, which is 22. Out of the second interface, it discovers a new device, configures the loopback IP on there as well. And then also the image upgrade process was skipped. It found a new device, and that new device was assigned the name BR2-2, and it has successfully provisioned those 2 devices and added both the devices into the inventory. So both the devices, like this is the process that happens in the background. Basically DNS center reaches out, the DNAC, the DNS center actually reaches out to the switch number 1, which is our seed device. It instructs the seed device to configure the appropriate IP addresses on all the interfaces that are going towards the switches, and so configure the ISIS password and everything. So everything is done. Everything is like provisioned. Everything is now configured via the DNS center onto these devices. So DNAC was automatically able to discover the devices, and you will notice not only these interfaces, you will notice that the IP address will also be configured between these interfaces, which will also answer your question that if we did not have these links, DNAC would still have configured the IP address on here and discovered this particular device.
But they're not showing the log.
Which logs?
That link. That.
No, because that device is already discovered now, so that will not show in the logs. This is only for like what devices got discovered and added and all those things. So that will not show.
So if the switch, as an example, the switch 3 connected to some like server or endpoint, is it going to add IP address to that interface?
No. Only between the switches. No.
Okay.
Only the underlay.
Yeah, but so you said the link between switch 2, switch 3 already discovered and add IP address between them.
Yeah.
So meaning if CDP neighbor not see switch or Cisco device, it will not configure it.
Yes, of
correct.
course. Like since LAN automation process is only with the help of the PNP and all those things, so it is only for the Cisco devices. Yes.
Okay.
If you have a router behind the seed device, that will not work. The seed device is the device that will be used to discover the rest of the devices. So no, until your router is compatible to be added via the DNS center, can be discovered via DNS center, and so that is okay. In that case, it's okay.
Are you going to show us the configuration on these switches?
Yeah. We will see that. So this is the process that has happened, and I can now go to LAN automation. It still says like in progress. It should have said like completed, provisioned. So it says like it is done. I think like we are good to now stop. Earlier, what happens like in earlier series, like in earlier versions of the DNS center, it shows like completed here. So then I hit the stop button. But let's see. Let me just go through it. So if you go here, you will see, if you reach out here, So this is our main switch, this is our seed device, and right here you can see, let's wait. This we are getting the log, so okay, anyway, so looks like these devices are now okay. So you can see that the devices are configured, this device is also configured, DNS Center is able to log in. So I guess like we are good to stop this LAN automation process now. So since like these devices are provisioned, like everything is done, I guess like now we can stop this LAN automation process. So if I click on this provisioned, yeah, here now it says completed. Now it says completed actually. So, but that's not the one. Today is not 8th July. So I guess this one is the old one actually. As of September 13. Okay, let's do one thing. Let's stop this LAN automation process. So looks like all the our devices got discovered, provisioned, and everything. So looks like we are good to stop this LAN automation now, because otherwise it will keep going on. So I will just click on the stop LAN automation. Hopefully everything remains as it is. So once I click the stop LAN automation, now what it will do, it started the initial resync for the devices. So once we see that the devices got added in the inventory and so now it will, now we need to stop the LAN automation process as well. So stop the LAN automation, the DNS Center will now start the resyncing of the devices. So stop in progress, again we need to wait for some time. DNS Center will log into these devices, and for example now here it will release that pool on the interface VLAN1 and also show run interface VLAN1, so interface VLAN1. So this pool, like this pool will be released and all those things, like so let's wait for this process to complete. Now once we click on the stop button, now actually the things happen in the background. So let's wait. Let's wait for this LAN automation process to stop. Yes, after all these things are discovered, you can do the local changes and do the resync and everything will work. Yes. Once we have discovered all the devices and everything, you can do the changes locally onto the device as well. Yeah. This is just to build the underlay network. Once your underlay network is built, once the reachability is there, then you can do whatever local changes you want to do onto the device. That is okay. So stop in progress. We need to wait. Starting the file. See now here, it released that subnet that it used for the LAN automation. So done. So now what happened? So devices got added to the inventory. Then we stopped the LAN automation. DNS Center started the resync process for the devices. It completed the resync on the devices. Then it actually converted those L2 links into the L3 links, completed the layer 3 conversion for the sessions of the tier 2 devices. It converted those configuring layer 3 interfaces for the session, completed the layer 3 conversion, configured the IP address on the interface, completed the IP address on the interface, completed the IP address on all the interfaces, configuring L3 interface sessions for 8 remaining links. So whatever number of links were there, on all the links, it will configure the IP address, and so completed the layer 3 conversion of the remaining link, starting the device cleanup, waiting for the device cleanup. Cleanup basically means like we are going to remove any additional configurations that might have been pushed by the DNS Center. Then the releasing the subnet for the LAN, it will also clear that VLAN1 and all those things that it has created for the LAN automation. Then it will release that subnet for the LAN automation, started final sync, completed the final sync, and completed the LAN automation. So once done, you can see here, once done, you will see that your LAN automation process is actually in the history. The LAN automation process is actually completed. You click on this, it will show you that this actually completed successfully. The 2 new devices actually got discovered, provisioned, added in our underlay network. One is known as BR1, BR2. So if I now check the configurations, what is done here? Show run interface VLAN 1. So nothing is here. Earlier, DNS Center configured an IP address on the VLAN 1, configured the IS and a lot of things. But now all that thing is gone. Right here you can see, I just checked it here. Right here I checked that the DNS Center had configured this VLAN 1 IP address and all those things. But now that is gone. So whatever configuration the DNS Center has done for the LAN automation purpose, once the LAN automation is completed, DNS Center is going to remove all those additional configuration. It will only have, see, all the 4 interfaces with the IP address go on here. In fact, username password is also there. Like everything, SNMP credentials, username passwords, everything that we have defined in the network settings, it will now be there. Show IP interface. Sorry?
Can we see the ISR?
We'll see that. So IP interface brief, check the IP addresses. You can see that the DNS Center has configured the IP on all of the 4 interfaces. Not only on the interfaces going towards switch number 1, but also on the interfaces going towards switch number 3. You can also go on here. You can also check it here as well. IMedita2, IMedita2 @123. Enable IMedita2 @123. Basically, whatever settings we configure, whatever settings, for example, we configured, whatever settings we configured on our network hierarchy, everything is now configured on here. All the SNMP configurations, all the show, run, pipe section, IP name, all the name server will not be there until we configure the IP. So all the settings, like for example, username, password, pipe section, username, all the settings such as, for example, the username, passwords and everything like is configured by the DNS Center onto these devices. So IP interface brief, pipe, exclude, assign. You can see that IP address is not only configured on 2 interfaces, but on all the 4 interfaces in between these devices here. Also, DNS Center has configured the loopback IP on here. It has also configured the loopback IP on there. Basically, and all to make the reachability, and so it has configured the protocol show, run, pipe section, router, ISIS. So it has configured the protocol like router IS, network selector address, type, domain password, metric, whatever. It also has configured like show BFD session, show BFD neighbor. It has also configured the BFD between the switches, so that like if the BFD sessions go down, the ISIS neighborship will go down as well. So all the things like show ISIS neighbor, show IP routes, ISIS, we can see all the L1, L2, whatever routes are there, everything. You can see that the seed device actually has configured a default route towards the neighboring devices, so that like everyone can use the default route to reach out to the seed device. From there, EIGRP is already running, so the reachability is there. So everything, whatever configurations are needed to be done to build the underlay network, those configurations will be pushed by the show run interface gig 1/0/19, for example 20, what was that, 21. See, you can see that on the interfaces it has configured the description, configured the no switch port, configured the IP address, configured the dampening, configured the ISIS, configured the BFD, configured the MTU, network type, show ISIS database. You can see that those LSAs, link state database, you can see in the ISIS as well. So everything you can see. Show ISIS neighbor, show IP protocols. You can see all the things that are required to be configured. It has automatically configured onto those devices. Show IP routes, ISIS. Even though you don't know about things such as ISIS, since it is completely automated, it just does not matter.
They have not configured that link to management switch, that switch to
Why
interface to management.
Is that part of the underlay? No.
No.
Okay. So LAN automation is for the underlay.
That port number 66.
Yeah. So LAN automation is for the underlay.
Yeah.
So only for the underlay. it could not discover a DNA compatible switch onto that. You can go on the switch number 2 and you can observe on switch number 2 right here, show IP into brief, pipe exclude and assign. You can see that IP address is only on the 4 links, not on the links going towards the this one. So, and if you scroll down the logs, you can see like what happened. It was an initial configuration dialog mode. Then what happened? Right here you can see crypto engine, some key self-signed certificate got generated, SSH got enabled. Automatically, we did not configure anything. That PNP process started, like PNP plug and play. PNP process actually started onto the device, right? PNP agent, automatic disabled due to user intervention console, whatever it is. Configured programmatically by process PNP agent. You can see that clock update, clock has been updated. You can see a lot of configurations was going on in the backend. See, it configured the IP address on the loopback 0, configured the BFD, configured the ISIS, new adjacency. Again, configured the other interfaces, BFD going up, interface VLAN 1, ISIS adjacency. Then the DNS center was able to push all the credentials and so that's why you get the login messages. DNS center has pushed the user ID passwords, so that's why we get the option. We get here that login messages and also. So everything happened in the background. We really did not need to do anything. And this feature is beneficial when we have like a lot of devices to build our Underlay network from the scratch. Then this is going to be very helpful. Even though you don't know a lot of things about like ISIS protocol, it will not matter because it is going to configure these things automatically onto here.
So level 2 for all the neighbors?
Yes, all the level 2 ones. Any questions?
Yeah, could you check like the seed device, downlink configuration, all the port?
Which one? Which device?
Yeah, seed device, something got changed, any additional config for switch 1?
Yeah. No. On the switch number 1, what has changed only like show run interface gig 1/0/19. So for example, here that interface going towards like, the LANs, the underlay side of that, there it has configured these things. Rest like it's as it was. So if you say like DNS center configured the VLAN, but after the task was completed, it has removed that interface VLAN, DHCP, show, run, pipe section IP, DHCP services, like nothing is running. So no extra configuration on the seed device actually.
Oh, just uplink only, okay. Like the downlink only.
Downlink, yes, the downlinks. Luckily, it is completed in first attempt.
So by default, ISIS is only taking the preference every time.
Yes, and that is why they recommend using ISIS in your environment as well. Because let's say for example, you already had this network built based on EIGRP, okay, and now you plan to add a few more devices right here. And you wish to use the LAN automation process, right? So to discover like these devices, and so you wish to use like LAN automation process to discover these devices. Now here you are running EIGRP. Okay, here because you are going to use the LAN automation, it is going to use the protocol such as ISIS. So ISIS, EIGRP, this will be used as a default route. This will be used as the default gateway. So there will be two protocols running in the same branch location, EIGRP, ISIS, which might not be like very desirable. So that's why they recommend that even if you are building the underlay by yourself, build it with the help of the ISIS only. Right? You also configure the ISIS here manually. And when the LAN automation is going to build the underlay network for you, it is also going to use the LAN automation. So there will be whole whole ISIS routing domain only. But not necessarily. As we can see that here we configured EIGRP, here we have ISIS. Still, the reachability and everything is there.
And the new devices below that switch 3, new switches, need to add that one. Then who will be the seed device for that LAN automation?
Switch 3 will be the seed. Switch 3.
Switch 3.
Yes.
So the password is not encrypted?
No, not actually. In the ISIS, the passwords that are set, actually, these are not encrypted.
There is no option on the DNA to make it encrypted password.
No. Not like yeah, we don't have any option like in the LAN automation process to encrypt this ISS password actually. No, not in general as well in from the DNA center.
Okay. And I'm assuming right now the DNA not in sync with the device that, or maybe I don't know, with the seed file.
Yeah, now it's okay. Now this one is okay. So now if you go to the inventory now, you will see those devices properly. You go to the inventory, you will see those devices here. You can see those devices and they will be there in the appropriate branch location. So you go to the USA, go to the New York and Wall Street, you can see those devices appropriately in that location. Yeah.
Okay, so that once you're done with that one, it's automatically sync it with the DNA.
Yeah, that will automatically sync it because when we were starting the LAN automation, we said that these newly added devices will be added into this particular branch. Right, so DNA assigned those devices to that particular site and configured like all the things and did the provisioning and everything. Yeah.
Okay, and remember yesterday we saw there's the running configuration is not matching with the startup configuration. Is it same thing right now, or it's automatically synced?
No, it's synced. It's synced because otherwise it will show you non-compliant.
Okay.
Now I don't. Yeah.
So actually, if I switch 1, switch 2, switch 3, I have manually added switch 2 and switch 3. Okay. And I have configured EIGRP, right? So after that, I have added another 2 devices, switch 4 and switch 5. Okay. So at that time, I went for the LAN automation. Okay. So whether I can use switch 1 as a seed device or not?
Switch 2 will be the seed device in that situation because that will be like, seed device is the device from where you wish to start the LAN automation process. If you start it from the switch number 1, it will jump to the switch number 2, then it will try to discover it, might take some more additional time. So you should use switch number 2 as the seed device to discover the newly added devices because up to this point, everything is configured. So use switch number 2 or switch number 3 from wherever you have connected new devices. So use those devices as the seed device.
So next thing is that if I switch 4 to switch 5 is configured with LAN automation and ISS has been configured, so we need to redistribute the routes from I.
No. I just now I explained that here we have the default route, just like switch number 1 was the seed device. It has given the default route, right, to these 2 devices. So if switch number 2 is being used as the seed device, it will give the default route here. And remember that the subnet you already have advertised in EIGRP, right? That's how it got reachable to the, so it will not matter because this will reuse the default route to reach to the switch number 1. It will use the default route to reach to the switch number 2. And the rest of the devices, since we have advertised these subnets in our like EIGRP protocol, that subnet 10.75.2 we have already advertised in the EIGRP. So back the reachability, the reverse reachability will also be there. So not necessarily actually. Now I don't like this name here. For example, this I don't like. I want to change it something like that so that things are going to be similar to this. So what I can do later on, like once everything is settled up, I can go here, I can just say configure terminal, I can say hostname BR2, this is switch number 2, I can say something like that, and I can say write, I can go on switch number 3, configure terminal, hostname BR2, switch number 3, and I can do the write as well. Now I can just select these 2 devices and just click on action, inventory, and resync devices. So once we do the resync, we will notice that DNS Center is going to again log into those devices. It is going to get the information from those devices and the host name will be corrected accordingly as well. That thing is later. Yeah, that thing can be done later on from the template tabs also, but nothing here need to be done. Here we don't need to do anything. Yeah.
So just a question. I'm not sure. Maybe it's asked. So in the future, as an example, if I have a expansion, add a new fabric, or expand my switches, add additional, like I have 2, 3, I add 4, 5. So can I repeat same process, LAN automation, and use my seed? Switch one is the seed.
Not switch one. You should use switch number 3 or 2 as the seed device, because these are much more like near to the switch number like 4 and 5. Use these devices as the seed device. Advertise these subnets into the EIGRP and also. So use switch number 3 and switch number 2 as the seed device, and you can repeat the process. Yes.
Okay, so it's not need to be. So since now they know how to go to the gateway to the switch one, now I can go use the other one, switch two.
Since like up to switch number 3 to everything is reachable now. So since the DNAC can reach to switch number 2 and 3, furthermore, like rest of the devices can be discovered from there as well.
Got it. Thank you.
We need to configure that EIGRP when we can configure from switch one to DNAC management.
Where we don't need to configure EIGRP? I don't get it.
Yeah, that switch 3 is connected to 4 and 5. The new devices will be, we want to LAN automation.
Okay.
Okay, then switch 3 to switch 1, there no need to configure the EIGRP again, because already they have the ISIs.
So, see, again, the point is that reachability matters. So this IP, this subnet that you are going to use, the 10.75.2.0 subnet, it should be reachable. Like, since we are using ISIs, you need to make this subnet reachable via ISIs from these devices to the rest of the devices. So reachability you need to make sure. No need to do any EIGRP or so right here. Here already ISIs is running. ISIs will be responsible to advertise the subnets and so. So if the reachability is there, your process will complete. If whatever subnets are being assigned here, if they are not reachable from the DNS center, reachability will not be there. As a result, your process will not complete. So reachability you need to make sure. Although there will not be any problem in the reachability, because you have already advertised that subnet via EIGRP to the DNS center. So reachability will be there, but if not, you will get a prompt that subnet is not reachable. You can make this reachable from there actually. So you need to make that subnet reachable. Whatever subnets are being configured on here for the LAN automation must be reachable from the DNS center. How you are going to make the reachability? That's
you have to. We need to advertise that on the switch one, that is the EIGRP.
No, you don't need to. You already advertised everything, na? You already advertised 10.75.0.0/16. You already did that. So the entire subnet, all the IP addresses, this IP is already advertised.
No, I'm advertising for new devices, the 4 and 5. That there will be a new IP address LAN pool over there. So we need to advertise that one as well.
Why? How can you advertise those IPs from here, switch number 1? How is that possible?
Oh, because the ISIS membership already there.
So how you can? Yeah, that's okay. So that will be done automatically now. Why do you need to do that? Why will you need to do that? That will be done automatically. The ISIS will be configured here. IP address will be configured here. That IP will automatically get advertised via ISIS to the to the ISIS. It is entire ISIS, na? That is the benefit of it. Since this is entire ISIS, this subnet will automatically be advertised in the ISIS. From there, it will automatically get advertised to the, like here.
From switch one to that DNAC.
So switch one to DNAC, you need to make the reachability. Yes, of course. Like from switch number 1 to switch number 1 to DNAC is already reachable. From the DNAC to here, you need to make the reachability. Whatever subnets are here, these subnets should be reachable on the DNAC. That's why I gave the entire route 10.75.2.0/16, because eventually the same subnet will be used on here or here. I don't need to do it. Why? Because I already configured a route such as, for example, 10.75.2.0/24 pointing towards the switch number 1. So no matter what devices we wish to automate, the IP address will always be from this subnet. So no need to do that. But yeah, if you have not configured that static route, if you are using EIGRP, you need to make sure that this newly added subnet gets advertised via whatever protocol you are using towards the DNS center. Yes, that is correct. You have to make that reachable. But you cannot make that reachable from like here. You cannot advertise these subnets from here to the management switch. You cannot do that. You cannot do that. You eventually need to do, you cannot go on the switch number 1, use the network command, and network this, network that. You cannot do that. That is not possible. This router will have all the routes. That is okay. Why? Because eventually this all is going to be ISIS. This switch will have all the routes. It will have this route, this route, this route, this route, all these routes it will have. But these two subnets, like these routes, are they available on the management switch? Let's cross check it. If you want to check it, you can go to the management switch and show IP EIGRP topology. Let's see. 10.2.75, 10.2.7.75.2, you see. So you go on switch number, you go on this switch number 1 here, branch to switch number 1, show run pipe section router EIGRP. Here, this is the only configuration that we did here. We did not configure anything extra. Right here, this subnet got automatically advertised in the EIGRP. This subnet automatically got advertised in EIGRP. This subnet automatically got advertised in EIGRP. This subnet also automatically got advertised in EIGRP. Because here we have enabled EIGRP actually. But this subnet will not get advertised in the EIGRP. And you cannot do it from switch number 1. You cannot do the advertisement of these subnet from switch number 1. Eventually, you will need to, like on switch number 1, redistribute these protocols, this ISIS protocol into the EIGRP. So that like these routes are reachable from the DNS center. But the best approach will be just configure go on the upstream device, configure a static route so that you can reach to the whole LAN automation subnet, so that you don't need to even worry about the reachability of these newly added devices. So reachability, yes, you need to make sure. You cannot advertise those routes from switch number 1. You cannot go on switch number 1, use network command to advertise these routes or this route. This is just not possible. You can only advertise the routes that are connected to you. You can only advertise the routes that you are receiving from other devices. So even though ISIS is configured, subnet A, subnet B will be received on switch number 1 via ISIS. But since we are not redistributing ISIS into the EIGRP, these subnets will not be available onto the DNS center, onto the management switch. As a result, reachability will not be there actually. So either you go on the management switch, configure a static route, or go on like switch number 1 and redistribute ISIS into the EIGRP. So that like these two subnets also get advertised in the EIGRP and they are now available on the management switch. Otherwise, your process will not work. So underlay, you need to make sure that it is completely reachable. Otherwise, like your LAN automation process will not complete. Right. So yeah, this is the whole process for this LAN automation. I guess like we did it not configure the domain name, show run pipe section IP domain. Oh yeah, looks like the domain name is also not there. IP domain name IMedita.com, and so it is just to build the underlay network. Rest you can still configure. Now I will resync once. So it synced the name, but now I'm going to resync. So inventory sync. Yeah. So yeah, let me know any more questions if you have. This is the LAN automation process, which takes some time. Sometimes it gets successful, sometimes not. So if you have missed anything from these conditions, it will just not start. If you don't have the reachability, it will just not. It will not be successful. It will give you the warnings, errors, and it will not be successful. So reachability, you need to make sure. What I did, I configured a route for that 10.75.2. I configured a route 10.75.1. So I don't need to worry about the reachability even if I add new devices. So yeah, that otherwise, if you have not configured the static route, you need to use the redistribution also to make that subnet reachable from the DNS center. This condition you need to fulfill right here. Here, LAN automation pool must be reachable from the DNS center. How you are going to make that reachable? That is your concern. you need to be aware of the routing between the DNS center and the switches, the newly added switches, so that the reachability can be there. If multiple protocols are being used, no doubt you will require the redistribution. If multiple, for example, routing protocols are used, such as, for example, here in our topology, here we are using EIGRP, here we are using ISIS. So redistribution will be required between EIGRP and ISIS to make the full reachability in the underlay network. But we don't need to worry about that because we already have given a static route on the management switch pointing towards the branch number 2. So that's okay.
So the loopback 0 for switch 2 and 3 taken from that subnet, right?
Yeah,
from that range.
Yes. Okay. Everything will be there from that pool. Everything will be there from the pool that we have configured for LAN automation. The links between the switches, the links on the IP address on between the switches, the IP address on the loopback, everything will be from that subnet only. Okay. We can correct it as well. If you want to correct it, you can go on the loopback and just configure the correct IP on there. You can do that, but not needed. But we can go on the loopback interface, do the changes, and just do the resync. And that will just like it reflected the names and everything here, it will reflect the IP addresses on here as well. We can also edit the device. We can go inventory, edit the device, and we can change the management IP right from here to one IP to other IP. So that is also possible.
Maybe too early this question. Is there a way to push a template configuration?
Yeah, we can push the templates as well. But for that, like first of all, we need to create the template and attach the template onto the branch. Then we will be able to do that. We will do that when we talk about like PNP process. There we will see like the onboarding and the like day 0 templates and the day end templates. We will see that.
Okay.
I'm also going to these devices with that. Yeah.
If I add a new devices, okay, and switch device will be changed. Okay, switch 1 to switch device will be switched to. So same IP pool can be used or different IP pool I have to
same IP pool. You can use the same IP pool, no problem. It knows like if you go to the IP pool now, if you go to the IP pool, it knows what IP it has registered. If you go to the IP address pool, you see 12% IPs are registered. It knows that. So it will use the rest of the IP addresses from there actually. It knows that.
Okay.
That's why you configure the /24 subnet so that further subnetting can be done and IP addresses can be assigned on the links between the switches. So it knows about that. If you go to the global, you can see 1% of the total IP address pool has been used by the devices in the LAN automation. So in the global, it shows like total like 98% IPs are still free. 1% IP address is actually used. You go to the New York, you go to the Wall Street. Here you can see 12% of the IPs are actually in fact in use. So no, you don't need to configure the pool again. You can use the same pool for the purpose. So this is the LAN automation process used to build the underlay network in an automated fashion. How does this begin? Here. So once we have made sure that everything, all the prerequisites are okay, then we will go to the menu, provision. Now this is from the old UI point of view. Earlier we used to go to the menu, then we go to the provision, then go to the inventory, then global, action, provision, LAN automation. They like there in older DNS center versions, this was the workflow. But here now they have just given that LAN automation and the provision, and right here outside the LAN automation. So you can see the LAN automation getting successful respectively. So what things you need to configure? Primary site, device, peer site. These things are no longer there. We do not need to configure any peer site, peer device. So this is no longer there. I can actually edit it right now. This thing is no longer there. Like this peer site, peer device option is no longer there. Peer site, peer device basically means like when we have transits and we have to configure like one device with the other. So that option was there, but this is no longer available now. So we need to configure primary site. where is our primary location where we wish to start the LAN automation process, what is our seed device, the ports. Discover device site basically means like once the devices get discovered, where are they going to be put? Then we are going to select the pool, then get the domain password. If you want to enable the multicast, you can enable the multicast, and then you can also give the host name for the devices that we wish to. Like if you want that the devices should start with some certain host name, that can you also provide. So this is no longer like in provision, it is now directly actually at, this is as per the DNS Center new version, it is directly under the provision, network devices, and the LAN automation. Actually, it is directly under here. So I'm just going to edit it here. So in the main menu, we go to the provision, and we no longer need to go to the inventory or so. We can just now directly go to the network devices, and we can begin our LAN automation process. In earlier version, remember that they always play around with the locations of the options. So you need to be aware where exactly are the options for the devices. So let me just quickly edit it. Yeah. Now it makes, so here, yeah. So now you go to the menu, then provision, network devices, and the LAN automation. Okay. So go to the menu, then provision, then network devices, then LAN automation. They have moved that option outside. Then we fill up the information, and then we can start the LAN automation process. Once we start, we can monitor the status of the LAN automation. Earlier, that option was also there in the inventory action provision, but now that option also has been actually moved to the exact location. It is like under the provision, go to the basically same provision, network device, LAN automation in the same process in the same location. We nowadays have the stop LAN automation option as well. So no need to actually give this there. This is also now at the provision, network devices, LAN automation, and we can monitor everything that is going on in the LAN automation process right from here. So here we have LAN automation. We can see the history. We can click on that, and we can click on the details about here. We had the logs, if you remember. Right here we had the logs, check logs. So here view session logs. So from here you can see, we can monitor what is going on.
So we need to stop the LAN automation.
Yes,
once we need to look at the log.
Yes, you need to look at the log. Not if you don't look at the log, once you go to the provision, you see this successful, stop the LAN automation. Right? Once you see that the provisioning of the devices is successful, you will see that actually right at this point here, added the devices to the inventory. Right here, you need to click on the stop button. So just keep on monitoring. Like here, initially it will show you on discovered. Then once the configurations are done, it will show you on the provision. Once you see these checkboxes, then you can click on the stop button, and then it will do the rest of the things automatically, configuring the IP subnets and all those things. Any more questions? Let me know. So this is it. This is done. This is how the LAN automation process is going to work. Next thing that we need to talk, this is done. So we have built our underlay network. Now what we can do? Now what we need to do, once our underlay network is built, now we go to the provision and we go to the fabric site, and we are going to build our fabric here. So if this page gets stuck, just reload it. Sometimes it gets clearer. So now we can build our fabric, and you can see that it will if you go to the tools and go to the topology, it will show you the topology actually, that you have two branches. In two branches, such as in one of the branch you have this topology, in the other branch you have this kind of topology. So it has actually detected the information about the topology as well. This is the kind of topology that you actually have on there, right? So see, right here it says two physical links. Right here it says two physical links. So one is down maybe. So here it says 2 physical link, here it says 1 physical link, 1 physical link. So other link might be down or something, might not have synced maybe. So it will show you, like if you mouse over it, it will show you the information about that particular link. Right, so 1 gig link is there. Here also you can see like multiple links are there, 2 links are there. Here you can see like how many links are there. You can get the information. So this is the basic view of the topology actually. No, in case of like automated underlay, this will be routed access layer. So this is pure layer 3, no ether channel, nothing. This is L3 link, L3, 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 IP address and everything. No STP, no VTP, no DTP, no ether channel, no VLANs, nothing. And that is the advantage of having the routed access layer, because we don't need to worry about those overhead protocols. If you are building the manual underlay, then you have the option which we will do tomorrow. So manual underlay, we are going to build a manual underlay. There what we are going to do, we are going to configure these 2 links in the ether channel link bundle, and then we are going to configure the EIGRP to make the reachability via EIGRP alone. Right, so that you know that not only ISS is not needed, we can also have the other protocols such as EIGRP. So if the LAN automation process builds the underlay, it will always be routed access layer. It will always be based on ISIS. Okay. So I guess that's it for today. We completed the LAN automation. Like I said, it takes a lot of time. So next thing, tomorrow what we are going to do, we will wipe these things. In fact, I'm going to delete all these things. I'm going to wipe, like, or I'm going to delete all these devices. Branch 1, I will leave it as it is, because on branch 1, I don't have anything to do. But these 3 devices I'm going to delete, and we are going to reconfigure all these devices manually. Some configurations I have already noted down in our notepad. I'm just going to copy and paste it, and then I'm going to use the protocol EIGRP to make this reachability, and we will rediscover the devices using the discovery tool. But this time I'm going to discover all the 3 devices at once using the discovery tool, and then by tomorrow also we will be able to build our fabric. So we will enable the fabric rules and everything. So tomorrow we'll build our manual underlay, and we will leave the things on manual underlay only. So we will delete all these and we'll start from the scratch again for the branch number 2 tomorrow.